continuing on learning Rust. I'm using this course from Microsoft called Take Your First Steps with Rust. Last week, if we come back here, I already did some of this. I did the get started and some concepts, but I didn't finish the concept section. Last week, we did a hello world, which every programming language gets you to do, but just a primer explaining what cargo is in terms of packaging things. And then we went briefly through creating variables, some data types, basically what you see on the screen here. And we stopped off at collection types. So I'm just going through the course online. Maybe you'll find this beneficial, maybe you won't. I'm just doing it to learn, and if people want to pop by and learn with me, hey, that's great. Let's get to it. So we're on indexing now here. I've been reading through the thing and then going through the exercises. If you have worked with Rust before, feel free to chime in. I've done mostly JavaScript in the past since 2016, but I have worked with .NET prior to that for most of my career, and C#, JScript, which is like Microsoft's version of JavaScript back in the day. In university, I did a very minute amount of C++, and they switched to Java after my first year. So managed memory. Rust, you need to manage memory like C++, but from what I've read so far, just seems to be a better experience. It appears to be a lot safer in terms of if things are in memory, you're guaranteed to have things in memory if you allocate. And so yeah, that's right, Angela. C++, C#, and JS. It's interesting how folks like to bring stuff from their languages to other languages. For those familiar with the JavaScript ecosystem, for example, async await actually came from C#. They don't have promises in C#, but they have something called tasks, and they used async and await as keywords to handle asynchronous stuff in I would say in a nicer manner. That got ported over to JavaScript and TypeScript. Can't remember who headed that, but Anders Hausberg, who created TypeScript, is also the creator of C#. Let's get to it. Today we're talking about indexing. I also created a repo for this while I was doing this course, but they have a playground and you seem to just go play in the playground. So it's like a REPL. So I'll probably stick to that unless there's an actual exercise where they say, like, you know, do this on your local or something. In this unit, your challenge is to fix the missing parts of each exercise's code to make them compile. You can use your local development environment or use the Rust playground to edit the code. In this exercise, modify the code for the two functions. Use the notation access to access the required elements of the numbers tuple and the letters array. So let's see here. Index, tuple, and function index array. I'm going to click on the Rust playground link. If I build this, I'm expecting some errors. Let's second Todo replace with the tuple indexing syntax. I just want to go back to tuples. Tuple, grouping of values, different types. That's by index. Okay, got it. If we come back to the playground, we want to get the second one here. I imagine I'm going to go numbers.1 since it's 0 based for indexing. If I build that, that should pass there, but there's probably another error down below. Let's see. Maybe we're better off just going into the repo. I'm going to make another file. Indexing exercise.rs. I'm going to paste this in. Cool. For the characters in the array, we want to get letter D. I'm assuming it's probably just like this. 0, 1, 2, 3. Gonna save it. Okay. One thing I discovered is Rust does require you to put semicolons at the end. I didn't clue into that right away. This should assert that D is letter D, and if not, it'll give an error message. I'm trying to see, how did we do this? I'm not going to worry about cargo right now. Let's just compile it. So I'm just going to move it down to here. I'm going to do Rust. Oh, it would help if I was in the console. Rust C and indexing. There we go. Let's compile that. Okay. Oh, it's not in main. So I guess there are advantages to having this in a main. Okay, let's do this. We need the main to kickstart things. From what I can tell so far, the order does not matter where you do this. I don't know if hoisting is a thing in here, or as long as it's defined, it should be fine. We want to do indexing. If I save that, function is, this is good. I was mentioning this on the stream last time. I like that Rust is very explicit. Hey buddy, you forgot this, or you know, heads up, try this, this is a warning. So I'll run both here and save that. Let's try this again. Warning, indexing array is never used. Just want to make sure I'm not seeing things. Okay. So indexing array is never used. Oh, geez. Copy paste error. Alright, let's run this again. Okay, so things went well. That means it compiled, and it ran these two and did its assertion. To prove that I did it correctly, I'm going to say 2 here. If I run this again, it should tell me 2 is not D. Really? What is it not doing here? 2. This is not the character. Interesting. Why does that not work? Why is that not failing? I wonder why that doesn't fail. Assert equals indexing array. Let's try it. I don't know. Let me try this one first just to see. Okay. So it seems to be doing fine with those, so why is that? I'm gonna go back to the playground here. We got numbers 1. If we come to D, letter D, this is gonna be characters 1, 2, 3, 4. Yeah, so 3. Let's build that, and it should assert correctly. Function is never used. Function is never used. Okay, that's fine. The warnings, because we're not having a main, but I want to see it fail. I don't know why it wasn't failing locally when I ran. Maybe it's because it was warnings. I'm not sure. I know what it is. It's not actually running it. So let's just try it, for example. But yeah, this is the same thing I was doing before, so I'm actually kind of confused. So if I do main, I don't know what's different, honestly, but let's go indexing tuple. Let's run that. Okay, let's get rid of the warnings, I guess. And this should compile. That's expected. Now, what I want to do is I want to make it fail. If I put 2 here, this should be 2 is not equal to 3. I don't know why I wasn't seeing this locally when I ran it, but okay, so that's good. It failed. Left 2, right 3. So we know we got it right. So that's good. I am still curious why locally I didn't get an error. I'm gonna literally copy paste what I just did here, because I feel like it was literally the same thing, but maybe it wasn't. That's okay. Let's try it. I just want to see why it's not outputting anything. Maybe I have to check maybe I'll have to go back to the existing exercise. It did run properly. I think the way the playground's set up, it runs the main. I gotta check why my main wasn't running, because I did the print ln and it still didn't do it. I just want to check real quickly, because like I said, I'm still pretty brand new. I did the hello world at the start there, but I'm wondering why when I ran it. Let's go to the hello world. It's because I needed to compile it and then run it. That's why. Go back one more. Let's get back to where we were. We were talking about indexing. We were just going over how to index stuff in tuples. As mentioned, come back here. When you want to access a tuple, it appears to be by not 0 based index, by 1 based index. I'm not sure why. We've got the indexing working. You access it by a one index. I don't know if that's the proper term because it's not 0 based. 1 based index. I don't know if that's the term. Dot 1 here is for the first one. Dot 2 would be for the second one. And for indexing array, I remember from C++ and C#, it's a character array, so you're just accessing it like an array item. All right, hash maps. We're going to be fixing the missing parts to fill in the hash map, I'm guessing. I haven't seen an import here yet, but this is how it looks like in Rust, I guess. So use is like import in JavaScript, or like in, I think it's been so long, but in C#, I'm pretty sure it was imports. This looks like a kind of a namespace for it. That seems to be the standard library. There's a collection section to it, and we want to have access to the hash map. This looks pretty familiar to myself in terms of TypeScript and C#. So hash map appears to be a generic, and in this case we're saying the key is a string and the values will be an 32-bit integer. That's what I'm guessing. I feel pretty confident about my guess. To feel a little more confident about my guess, I'm going to give Todd a little nudge on the screen there. You only need to edit the fruit basket function in this exercise. I'm going to go into the Rust playground. We need to modify the fruit basket area, and hopefully I can figure this out. So it says it looks like mutt. I don't know how they pronounce it, but it means it's mutable, because everything by default, from what I learned last week in Rust, is immutable by default. I think that's a good default. This is saying that the basket is immutable. Declare your hash map here, and then basket, insert string from banana with the value to, I'm gonna guess it's, I'm trying to remember how it is, but let's guess new hash. I'm guessing you're just gonna do this because it's a generic, and we'll do this, and we need to instantiate it so we get an instance of it. This becomes a mutable basket hash map, and you don't need to pass, that was the other thing I learned last week, you don't need to have an explicit return keyword when you return something in a function if it's the last thing in the function. If I was up here, like if I had an if something and I needed to exit for whatever reason, I would do return here. But, and I think I've seen this in Ruby too, the forum code base is a Rails backend, and I don't work in that part of the code base normally. I'm focused on the front end, but I think I've seen this in Ruby too, where you just say whatever it is at the end there, and that's what you return. This looks like we're just gonna, this function just is, it's kind of like a very simplified factory pattern. It just gives you a fruit basket. Okay, and then in here, the main, it's gonna say, let's get that fruit. We're saying here, let's create a new fruit basket. We want to assert that the fruit basket has at least 3 types of fruits, and the basket must have at least 5 fruits. That seems like a kind of handy thing here. So it looks like, I'm kind of curious how much inspiration Rust has from JavaScript as well, because this looks like, you know, with object, there's like, you can get entries and stuff, and you can get values. And that's what this looks like to me, because everything in JavaScript is an object, which is essentially a hash map to some degree. Like I was saying, I feel like there's some inspiration from JavaScript here with the dot values. I really like this kind of handy function here off the values where you can just say sum it. Maybe they're inspired from Excel, who knows. We need to have at least 3 items and 3 different types of fruits and at least 5. We need at least 3 types of fruits. I'm gonna copy this. I've been eating mangoes lately, and we need to have at least 5 fruits in total. I'm gonna go with 10 because we're having an extreme injection of vitamin A. I've also been eating a lot of honeydew. Let's go with 3 honeydews because we don't want to make our fruit basket too heavy. Although I do work out. This should create a new hash map, which appears to be a generic type, and the key is going to be a string, and the value is going to be a 32-bit integer. We're inserting at least 3 different types, and that should hopefully assert things properly. Okay, I'm clearly not instantiating it properly. I think I have the rest right. I'm just trying stuff because I want to see if it's into compiling playground error expected. Interesting. I wonder if it's this. I will go check after this if it doesn't work. Okay, I don't know. So let's go back here and check real quick. I only started streaming this last week, but I do like that there's some things that are familiar in here. So let's go to data types again. Let's look for hash map. No, it's not in there. Oh, it's in collections, sorry. Let's go to hash map. It is a generic, so KV. I know some folks in JavaScript land, or I should say TypeScript land, they don't like it when the generics use letters like this. I got used to this from C#. Usually you would have, it was always like, for example, new set of T, which probably stands for type, but it was because there's only one key. When there's a couple, I still think it's okay because these things are generic. If you can give it a name that still keeps the representation as a generic part of it, go for it, but you know, whatever makes it readable. Okay, this is my first lesson in Rust, so you're not doing new. I was writing it more like JavaScript or C#. It looks like to instantiate something you need to do : which means to invoke the new function on it. In this case here, they're giving the type here. That's like TypeScript in terms of setting the type. Let's go back here and let's do this again. I want to try one thing first here. Since the signature here says it's returning a hash map where the key is a string and the value is a 32-bit integer, I want to see if I can instantiate this and Rust knows to infer that it's of this type. That's the first thing I'm going to try. If that doesn't work, I will explicitly set it. I feel like this would work. Yeah, it did. Just for funsies. Let's do this, and that should run too. The playground takes a little longer. And if I do this, I would expect it to fail, or give a warning at least. Unless the 32-bit integer is able to squeeze into that, like it knows that it can work in there. Maybe that is what's gonna happen. Timed out. Anyways, all that says Rust is able to infer the type here, which I think is pretty neat. If we come down here, I've got 15 fruits. If I say 16 here and run, I would expect, it's gonna say basket must have at least 5 fruits. It really should be at least 16, but okay. Let's just move to, we'll go back here. So what was that exercise called? Hash maps, yeah. I'm just gonna create files here. So let's do touch, just because it's gonna run faster in my local. Hash maps exercise.rs. I probably could have just done code hash maps. Anyways. Okay, let's pop that in here. It's literally what we did. I'm gonna put this back to 5 fruits. And I'm going to do Rust compile. And then we want to do hash map exercise. It compiled it, and now I need to run it. And this should run fine. Now, let's put it to something we know will cause it to fail. It should compile fine because the asserts haven't run yet. Now if I run it, I'm expecting it to say the basket must... Yeah, okay. It should. I didn't change it to say 16, but we're seeing it happen. That's awesome. Let's move to the next one. Iterate through code with control flow, good old if-else. Not going to dig too deep into what they have here, but this is interesting what I'm seeing here. if blocks can also act as expressions. That's pretty neat. I wonder if this is because they must have ternaries as well in Rust, but maybe using the if as an expression is to make it less terse. And it probably also avoids having to say if formal greeting equals good evening, else greeting equals hello friends. So that one seems pretty straightforward. I'm not going to run it in the playground or locally. You can have multiple conditions, so you can do else ifs. That makes sense. This program has 4 possible paths you can take. After running it, you should see the following output. Okay, so number 6. Okay, yeah, that makes sense because 6 mod 3 will give you 0. There's no remainder. 6 mod. It could end up being numbers divisible by 2, but given the order of the if-else's, it's going to hit the 3 first. So any subsequent else if or else block is skipped. Conditional expression evaluates the follows. And loops, you don't even need to do a while true or something. You can just say loop forever. I guess that could be for maybe just something continually monitored. Unlike other kinds of loops in Rust, like while and for loop, loop can be used in expressions that return values via break. Interesting. So this is just another way to set a variable. That's interesting. I wonder why they do that. There must have been use cases, or these are things they thought were missing from other programming languages. What happens here is starts off as 1. It loops theoretically forever, but it's saying I is equal to itself times 2, keeps compounding, and if I is greater than 100 break, it should equal to 128 because powers of 2. Every break a loop has must have the same type. That makes sense to me because you're setting the value of something if you're using it as an expression. So you couldn't say like let it be a string if this case, otherwise return a number in another case. It's mutable because we're starting it off as 1 and then we're gonna set it, we're incrementing it. I like the idea of making things immutable by default because then if you explicitly say I want to mutate something, you're aware of it. We have a while loop, which is common in most C-based languages like JavaScript, C#, C, C++. In this case, we have the counter again. It's mutable. We're going to say loop until the counter, as long as it's less than 10, and then we're just going to keep printing hello for like 10 times. I'm not going to do these in the playground because I feel like these ones seem pretty straightforward, but if you happen to end up taking this course, definitely peek. Okay, cool. Let's keep looking at the loops here. For expression extracts values from an iterator. It loops until the iterator is empty. That's nice. So here 10, 20, 30, 40, 50 for each element. So element's going to be 10, 20, 30, 40, 50, and we print out the value. I like this a.iter instead of having to do an explicit .next and stuff. We can run this in the playground though. There. And we can do this in, I believe that should print 5 times. There we go. Like we saw, so this just looped through, going through all the elements. I like that it just keeps going until it runs out of stuff. In this case, for example, if we had an empty array, I know it looks obvious, but it should probably not print anything. Oh, okay, it can't that makes sense because the type of the array is ambiguous. So is it this? U32? I would have thought it would have been more exciting than that, but I guess we have to explicitly say 0. And since it's I'm not going to make it mutable, but if I run this should say that the type of the array is an array of 32-bit integers. There's none in the list. And the iterator should work, and it's just not going to do anything. That's awesome. I know we don't need to explicitly set it because we have a number in there now, but this should output the value is 1. I'm curious if I set it to 2, but only put 1 element in there. I would expect it to throw an error, given that Rust seems to complain if it doesn't like things. I keep saying this, but I love how it tells you in a very verbose way, well, this should work, and we should see the value is 1, the value is 2. We do the iterator. The preceding code, it iterates through each element in the array and binds it to the element variable. Then the print ln macro prints it out. Another easy way to create an iterator is to use the range notation. So note, this notation yields values from A inclusive to B exclusive in steps of 1. So the preceding code iterates through 0, 1, 2, 3, and 4, because it's exclusive. It's not included the last one. This prints out 0 for the first one. The next one is the number 1 times 2, so that gives us 2. The next number is 2 times 2 is 4, and then 3 times 2 is 6, and so on. And we skip 5 because, as it says in the documentation, when you're using the range notation, the last one in the range is not included. We're going to work on handling errors now. This is 34 minutes, which maybe we'll get through, but if not, we'll continue on next week. There is a panic to deal with unrecoverable errors. I like the name. Little Panic at the Disco. Use the option enum when a value is optional or the lack of a value is not an error condition. Use the result in when things could go wrong and a caller might have to deal with the problem. You're kind of offloading the problem to someone else to see if they can do something with it. Error handling is a process of anticipating and working with the possibility of failure. Let's do a panic example. Let's do code errors panic example. .rs. You can do touch to create the file, but I've discovered if you just do code, it opens the file. It hasn't created the file yet, but as soon as you save it, it will. Let's compile that. So rust c error panic example. That should compile. And then if I run errors panic example, oh no, farewell. That's expected. In general terms, you should use panic when a program reaches an unrecoverable state, meaning anything where there is absolutely no way to recover from the error. That's interesting. It also brings up a good point. This is in Rust specific. Yeah, we're looking at error management in Rust. So the first thing we're seeing here is there's this panic. And so panic, I'm still not sure what the difference between a macro and a function is in Rust yet, but if it's a macro, you have to postfix it with an exclamation mark. For example, print ln is a macro as well. In this case here, panic is really like, you do this when you're like, yeah, we're effed, nothing you can do. It's just really to say, can't recover, abort, send for backup. If I come back to the code example and I rerun it, it's gonna say, farewell, panicked. Now we're going to look at an example with a vector. This here is saying create a vector with 4 things in it, and then we're going to try and access something in the 6th slot which won't exist. Never mess with macro languages yet. I know macros from like Excel, which to me are just, they seem like they're just functions that you happen to run anyways. In terms of Rust, at least so far, I don't know what the difference between a function and a macro is. It'll be interesting to find out. This one, we're expecting this to panic because it's trying to access something in the 7th slot of the vector, and there's only 4 items. Let's run that for fun anyways. There's one panic. Let's do this one. I'm gonna recompile this. It's all good. Now it should panic because it can't access things. I keep saying this, Kirk, to whoever's been on today, but I really like the error messages that Rust gives you. They're very explicit. There's no obscure messages. Let's literally read this. Panicked at, index out of bounds. The len is 4, but the index is 6. I don't think you can get any clearer than that. I think that's probably gonna be one of the amazing things of this language. There's the option type to deal with absence. Again, is a generic. We were talking about this before you came on, Kirk, but Rust has the notion of generics as well. So like the hash map that we were doing prior to you coming here, that was a hash map where the key was a string and the value was a U32, so a 32-bit integer. Same thing with option T. This is an enum and it's used for the absence. So none or some. It's not that I put it off. I started doing Rust like a year and a half ago. I didn't spend a lot of time on it, but the reason why I was interested in it is because of WebAssembly, WASM, and because that's directly related to web development. You can create better experiences if WebAssembly is enabled. One of the ideas I have is, at least in the context of forum, is when folks upload images or even potentially videos, instead of processing that all on the server, if we have WebAssembly enabled in the browser, if WebAssembly is available, why not offload all that crunching to the browser, let WebAssembly run and do stuff like resizing the images before we even upload it? That was initially like my thinking in terms of Rust. There's definitely other things you can do with it. You can do console apps. Parts of the Linux kernel, I believe, are already starting to be replaced with Rust. I'm not 100% sure of that, but I feel like I've read that in the past week. So option T here to me looks like, you know, yeah, it's just optional. It's not an option, it's optional. So it's either there's none or you have some of something. This kind of makes me think of TypeScript's partial. I don't know if they got inspired from that, or I feel like these are probably functional programming concepts that exist in Haskell or other functional programming languages. There's also the maybe type and all that. I have a feeling we're going to come across those things. Yeah, I think TypeScript must have taken some inspiration from functional programming as well in that sense. It's saying option T, so I imagine that's saying option T, so say it was option my type of variable. It's either nothing or some of it. Let's look at a concrete example. Let's go back into the terminal. I'm gonna create a new one. We'll call this errors option enum.rs. Let's do fn main so that it'll run. And let's bring this in. I'll figure it out after the stream, but I'm pretty sure this is supposed to auto format. The kerning makes sense. I've done that in JavaScript before, because then you can kind of, the canonical example I've seen is applying multiple things to a piece of text, for example. If you can curry it so that it only has the one parameter, then you can say some text, you know, bold it, italicize, make it big, you know. I'm sure there's other canonical examples, but that's the one I've seen before. No, the partial application makes sense. Yeah, and I guess that's just how you can keep piping things too as well if you go with the partial application or the currying, I'm assuming, because that's what I've done in the past. Not in a functional programming language, but in JavaScript. Let's take a peek here. We have a vector. I guess the difference between a vector and array is that the vector, if I made this mutable, I can probably just keep adding to it. Whereas an array, you have to give it a specific type. I'm guessing that's the difference, but we'll see. We got a vector, banana, apple, coconut, orange, strawberry. First fruit should be banana. Third one, coconut. And this one is non-existent, which makes sense. Oh. In this case here, fruits.get non-existent, and I'm guessing this syntax is like in TypeScript, use the question mark for optional. I'm guessing that's what that means. Let's just compile this. I gotta look into it after the stream, but I imagine instead of just compiling, I can just say run it, but maybe I have to. Let's see. Boarding, couldn't read, errors, option. It would help if I saved it. There we go. Okay, that compiled. Let's do errors, option none. So it outputs banana, coconut, and then none. Okay. We're creating a vector, and basically what's happening here is I'm printing out things in the vector at certain indices, but then the last one is trying to get one at a non-existent spot. Instead of returning something, it just says none. And interesting enough, I guess I can't tell here, but I'm trying to see where it knows it's either some or none. I'm trying to understand how it knows it's an option of T. I guess that's what the vec exclamation mark maybe? Let's see here. The printed message just says the first two temps at existing indices, so that's normal. It says some banana, some coconut, but the one at the 99th element returned none because there is nothing there instead of panicking. I guess I can see why you would want to do that. In some cases, you're just like, this is not a critical error necessarily. You're just like, yeah, there's nothing there. So, and you can handle that yourself. Okay. I still don't understand how it knows it was option of T though. Let me see here. I'm just going to read through again. I think under the hood vector is of option type T. That makes sense. I thought we were going to be doing explicit setting the option T there. Exactly. There's no point in making your program just die because you're like, yeah, sorry, that's not in the index. Unless there's like a really valid reason why you would have to stop the program because something wasn't there. Yeah, the panic, like they were saying, is for like stuff you just can't recover. And the thing is, I remember when I was starting off programming, I would think when, error handling, how do I do this, And the thing is, when you do try catches, you're expecting an error in a certain case. It's known, like something is going to happen, and then I am going to try and handle it. Then there's the unexpected errors. I know like in JavaScript land, there's like a windowed on an error or like uncaught promises and stuff like that. And you can hook it up to something like, we use Honey Badger at Forum, but there's other stuff like Sentry or anything. And those unforeseen errors get logged, and then you can investigate, and see what's going on there. You usually have your try catches and stuff because you're like, I'm expecting something not to work here in this scenario, and then I will deal with it. And that's something I didn't really grasp when I started programming, I think. I was just like, put the whole program in a try and catch, and then it's like, oops, something didn't work. Maybe that was just me. We're looking at pattern matching now. I know this is coming to JavaScript. This might be a good place to stop. We can resume next week with pattern matching, so that'll be a nice little cliffhanger. I'm pretty excited to check it out. I read a little bit about it because I know there's a proposal for JavaScript and pattern matching. I don't know what stage it's at. I can't remember, but I'm looking forward to that. Thanks for everybody who popped by today. I will see you all next week. Take care.